Hello, and welcome to the third grade motion assessment overview video. My name is Katelyn, and last spring I was one of 6 teachers at Barclay and Warwick that experimented with our new motion assessment. This year, many of our schools will be piloting this assessment. The purpose of this video is to give you an overview of the different parts of the assessment, the supporting documents, and the setup. All of the documents that I refer to in this video can be found in a folder called Motion Assessment Documents in the third grade Science intranet page. These will provide much more detail than this overview. In addition, during the month of October and early November, we will have after-school workshops for the assessment. The motion assessment is broken into 5 parts. Here is the rubric document. The rubric is broken into 2 skill sets: Practices of Science and Science Knowledge. Parts 1 and 2 contain the knowledge and practices of science, while parts 4 and 5 are only assessed under Science Knowledge. The assessment is designed to be progressive, moving from group work in Part 1 that is very concrete, where groups of students actually use their bodies and a whiteboard to recreate motion graphs. Then a little less concrete in Part 2, where groups of students recreate motion graphs using the track and ball behind me, to more individualized assessment parts, like Part 4, where students analyze data using Excel. And then finally in Part 5, demonstrate understanding with an individual assessment combining multiple choice and short constructed responses. You'll also notice that between the group work and individual work, teachers have a chance to perform a formative assessment with the class in Part 3, where students formally talk about the concepts in the motion unit and try to clear up misconceptions together. Then students complete a self-evaluation, which the teacher can use to pull small groups and reteach key concepts before moving into parts 4 and 5. Okay, now let's take a closer look at the different parts of the assessment. In Part 1, students will be working in small groups of 3, using a laptop with specific software, a motion sensor, and a student whiteboard from your everyday mathematics lessons. The software that you're using is called Logger Lite and should already be loaded on your teacher presentation station and one laptop cart in your school. Here is a quick shot of the front and first page of the Part 1 document. Part 1 is called Cooperative Exploration. I'm going to model the first task. To start, the students will need to mark with masking tape the start and stop distances in the tasks. For this task, I need to start at 0.5 meters and end at 2 meters. The entire time for the trial should take 5 seconds. Having this distance marked will ensure I produce consistent results each time. This is a key concept to stress with students. In Part 1, students will hold a student whiteboard in front of them. And here we go. For Task 1, I'll start at 0.5 meters from the Go motion sensor and move away to 2 meters from the sensor in 5 seconds.
All right, I'm going to go ahead and hit collect. Ready, set, go. All right, nice job. It's a good looking slope going up. I'm going to go ahead and hit the store icon here, and then I'm going to try and match it.
Before Scientist 2 makes his run to attempt to recreate the graph, we've stored the previous run and the line is more narrow. So now Scientist 2 can attempt to recreate the graph with his motion. Okay,
I'm ready.
All right, go. Now Chad's graph is very similar to the first graph, which means he has successfully recreated the graph using the same motion. And we can then hit store, and Scientist 3 can make his run. Here is a quick shot of the front and first page of Part 2. Now I'm going to do the first task in Part 2, called Cooperative Application, and model it for you. In this part of the assessment, things become a bit more abstract, as students will be using a track and ball and recreating graphs, rather than using their bodies to create graphs. The track is about 2 meters long, and here we go. This is Part 2, Task 1. In this section, we'll be attempting to recreate this graph. There are multiple ways to get this graph, so we'll show you a few options that your students may explore. Ready?
Yep.
So here we attempted to recreate the letter M. We got very close, so we would say this is an acceptable graph. Another way we could have done this, Chad's going to show you another way that you or your students could recreate this graph.
So in this example, I'm not going to be pushing or I'm literally going to be pulling the ball, and I'm just going to do it alone. Ready to collect?
Mm-hmm.
Okay, go ahead. So you can see they're pretty similar. I also made the letter M. You can see how different the collection was.
And there may be a skew marks, which we told our students that this was okay, and it's just the equipment. When students have completed parts 1 and 2, small groups will gather and use a conversation protocol that we have developed and provided to help them process and learn from the first 2 parts of the assessment. This is called Part 3, Cooperative Conversation. This discussion is important for learning and has been found to help eliminate misconceptions that students may have about motion. It also gives the teacher valuable feedback about students that may need some key concepts retaught before moving into the more individualized parts of the assessment. There are 2 documents that you may refer to for Part 3. Here's a quick shot of those documents. For Part 4, we have created 3 versions of the same assignment for you to use as you judge best. In Part 4, called the Individual Synthesis of Science Knowledge, students make predictions about a given set of data. They then input the data into a spreadsheet in Excel to create a graph. They identify similarities and differences between their prediction and the actual graph. The students explain what happened to create the graph. For example, in this version, the graph angles up. Students will recognize that the motion began close to the sensor and moved away at a steady rate. This motion may have been created on the playground when one student threw a football down the field to another student. The motion began with the throwing student and ended with the student catching the ball a few meters away. Here is a shot of the individual assessment for Part 5. We'll use a draft form for this year and modify it as needed for next year. Part 5 is an individual assessment that each student completes on his or her own. The questions from this part of the assessment are multiple choice and short constructed response. These questions come from state and national science assessments. Now that we've looked at the assessment, let's work backwards to the supporting unit plan. We have also produced a document which suggests a day-by-day timeline for our Science Companion unit and tie it together with our assessment and our goals for the unit. We'll end our overview video with 2 short clips of students working on the assessment last spring at Warwick. Thanks for watching, and good luck with our pilot motion assessment this year.
These 2 and these 2, how are they similar? So this one, this one?
Okay, here we are with this group, and look at their lines. They're so close. Tell us what happened.
First, all of us planned to start here so that we would be really near to each other.
Okay.
Then Allison, who science is 1, started here and moved slowly.
So Allison, you started?
Yeah.
Okay. Good. And then who went second?
Anthony started.
Anthony, you went second?
Yeah.
All right, nice job, Anthony.
And then I went last. We all started this and then moved back slowly.
All right, good job, guys. And all 3 lines matched up very cool.